the fundamental force. Welcome to MathGPT. Today we'll explore the fundamental forces responsible for attraction and repulsion in our universe. There are four fundamental forces in physics: the gravitational force, the electromagnetic force, the strong nuclear force, and the weak nuclear force. Each of these forces plays a different role in how objects interact with each other. Many everyday phenomena of attraction and repulsion that we observe are often misattributed to nuclear or gravitational forces. However, it's important to understand that neither nuclear attraction nor gravitational attraction are primarily responsible for the common attraction and repulsion processes we experience in our daily lives. The force that dominates most attraction and repulsion phenomena we encounter daily is the electromagnetic force. The electromagnetic force acts between electrically charged particles and is responsible for electric, magnetic, and most chemical phenomena. To understand why electromagnetic forces dominate our everyday experiences, let's compare the relative strengths of the four fundamental forces. Let's look at how electromagnetic forces cause attraction and repulsion. At the atomic level, particles like protons have positive charge, while electrons have negative charge. Like charges repel each other, while unlike charges attract. Now, let's look at some real-world examples where electromagnetic forces are responsible for attraction and repulsion, not nuclear or gravitational forces. First, let's consider magnets. When two magnets interact, the attraction or repulsion we observe is purely electromagnetic. The north and south poles of magnets create a magnetic field due to the alignment of electron spins, which is an electromagnetic phenomenon, not a nuclear or gravitational one. Another common example is static electricity. When you rub a balloon on your hair, electrons transfer from your hair to the balloon, giving the balloon a negative charge. This causes your hair to be attracted to the balloon because of the electromagnetic force between the charges. A third example is chemical bonding. When atoms form molecules, it's the electromagnetic force between electrons and nuclei that creates the bonds. For instance, in table salt, sodium chloride, sodium atoms give up an electron to chlorine atoms, creating an ionic bond based on electromagnetic attraction. It's important to understand that nuclear forces operate on a much smaller scale than the phenomena we've been discussing. The strong nuclear force only acts within the atomic nucleus, binding protons and neutrons together. It has an extremely short range of action, about 1 femtometer, 10 superscript 1 meters, which is roughly the size of a nucleus. Similarly, gravitational force, while universally present, is far too weak to be responsible for everyday attraction and repulsion phenomena. Gravity is about 10 superscript 3 times weaker than the electromagnetic force between charged particles. For example, a small magnet can easily pick up a paper clip, overcoming the gravitational pull of the entire Earth. In conclusion, most common attraction and repulsion phenomena we observe in everyday life are due to electromagnetic forces, not nuclear or gravitational forces. Remember these key points. 1. Electromagnetic forces are responsible for electric, magnetic, and chemical interactions. 2. Nuclear forces only operate at extremely short distances within atomic nuclei. 3. Gravitational forces, while universal, are far too weak to explain everyday attraction or repulsion. Understanding the true nature of these forces helps us correctly interpret the physical world around us.